NASA's Space Science Data Coordinated Archive, or NSSDCA, ensures that valuable information collected during NASA missions is preserved for the long haul, sometimes even decades after the mission ends. In this video, we'll walk through how NSSDCA handles ingestion, migration, archiving, and accessing the data. We'll also show how new tools like Black Pearl are helping us archive faster and smarter. The NSSDCA is responsible for various data archive activities, including but not limited to accepting and processing archival data submissions, creating data collections from submission metadata, ingesting and archiving data, migrating data from older formats to ensure preservation over time, and fulfilling requests for data. These processes are all defined under the Open Archival Information System, or OAIS, reference model. The OAIS is a framework that helps organizations develop and implement data preservation strategies, and is used by the NSSDCA to determine the components and standards of our digital archive. Some of the terminology you will hear in this presentation comes from the OAIS model. The NSSDCA accepts data submissions from active archives and missions funded through the Science Mission Directorate. This data can come in various formats. For Planetary Data System, or PDS data, we accept both older PDS 3 format and now the newer PDS 4 format. We identify all other data as non-PDS. PDS nodes use the PSI to submit PDS 3 and PDS 4 data. The nodes also use PSI, or the PDS Submission Interface, to view status reports of their data submissions and are able to follow the archival process all the way from preferred to archived. Recently, there's been additional reporting functionality added to PSI at the request of the PDS Engineering Node, which allows for users to retrieve status reports in JSON format via URL query string. This has allowed for PDS Engineering to streamline their own status update process. Even though PSI can be used by the nodes to manually submit PDS-4 submission information packages, or SIPs, most SIPs are automatically pulled over from the engineering node by our PDS-4 SIP submitter. This process runs daily to retrieve any new SIPs posted by engineering. Non-PDS data bypasses the PSI and is submitted directly to our Java interface for metadata in XML, JIMix, by our science staff. JIMix is used by NSSDCA science and operations staff to validate submissions, extract metadata, and shred the metadata into new or existing NSSDCA data collections. Once this is done, the submission moves on to be ingested. PDS Val Pro is an automated version of JIMix used for PDS-4 only. In the future, PDS-3 metadata processing may become automated as well. NSSDCA's Master Catalog, NMC, is a public-facing site wherein users can query information we have stored in our NSSDCA Information Management System, or NIMS. This includes information on spacecraft, experiments, associated personnel, relevant publications, and all data collections created from archival submission metadata. Once our NSSDCA data collections have been created or updated using the archival submission metadata, it is time for the ingest process to begin. For PDS-3 and non-PDS data, the submitting node uses a specialized software package called XMan to generate a delivery manifest. The node then provides this manifest to operations staff at the NSSDCA. Operations uses this delivery manifest to pull over one or more data volumes via our PDS puller process. The puller validates the checksum of every file that is pulled over. Once the volumes are downloaded, additional data validation is performed by xcheck before our SIP Pro software packages up all the data into a single archival information package, or AIP. Once the AIP is generated, this PDS-3 or non-PDS data is ready to be archived. For PDS-4, the delivery manifest is generated by the submitting node using software provided by engineering and included upon submission to the NSSDCA. Our PDS-4 SIP pipeline performs many very strict validations on the submission information package, the delivery manifest, and each and every PDS-4 product provided by the manifest. This could and has reached into the millions. Once validation on all the products is complete, the PDS-4 Parallel Puller and Package Daemon, or P4D, processes each PDS-4 product in turn. This means pulling over the product data files, validating checksum information for each data file, and packaging into an AIP. So unlike PDS3 and non-PDS, where a single AIP is created for entire data volumes, for PDS4 there's an AIP generated for every product, which, as we mentioned, could and has reached into the millions for a single SIP delivery. Once all AIPs have been created by P4D, this PDS4 data is ready to be archived. The ingest process, regardless of PDS3, PDS4, or non-PDS data type, has been one of NSSDCA's bottlenecks for over the past few years. With the introduction of PDS4, as well as lots of big data coming our way, such as the Catalina Sky Survey, LROC, Atlas, Arecibo, just to name a few, we needed to find a way to pull over, validate, and package up the data faster. We are happy to share that over the past few months there have been major improvements made to the ingest software suite, and in addition to equipment upgrades, this has greatly improved our ingest processing speeds across the board. We are seeing an average performance increase of 50 to 70%. To give a specific example, prior to those updates, one Catalina Sky Survey delivery could take several weeks or more to process to completion. Now they're taking an average of 24 hours. Another example is LROC. Pulling over an LROC volume could take days, now takes hours. There are even more software improvements in testing as we speak, and we are excited to see how much more our ingest process performance continues to improve. Speaking of new and improved, in October 2024, we launched NABS, the NSSDCA Archival Black Pearl system, our fully modernized archival platform. NABS is built as a suite of custom microservices that run in parallel, allowing us to archive AIPs much faster and more efficiently than ever before. These services work in tandem with the Spectra Logic Black Pearl server, which acts as a smart controller for moving data into deep storage, and the Spectra Slack Tape Library, a scalable and high-performance solution for long-term preservation. With this new architecture, we've dramatically reduced the time required to archive submissions. Where our legacy system often took days or even weeks to complete large data ingests, NABS brings that down to just a few hours, even while performing required validations. To consider an AIP fully archived, we still write 2 copies, one to a primary tape and one to a backup. And of course, validation checks continue to ensure data integrity. Before we deployed NABS, we had a significant backlog, partly due to issues with our old tape library, but also because the volume and size of data had begun to exceed what the old system could handle. Thanks to NABS, we've caught up and we're staying caught up, archiving as fast as we can get the data ingested. NSSDCA performs data migration in order to ensure all archived data is preserved and remains accessible over time. Currently, our data migration process is done manually by our operations staff, who are currently in the process of migrating LTO7 tapes to LTO8. LTO stands for Linear Tape Open and is a standard tape format which offers high storage capacity and data transfer rates. In the near future, our Black Pearl system will be set up to automatically migrate AIPs from older to newer media as a background process. Black Pearl will handle the migration of AIPs from LTO8 to LTO9 and even LTO10. As we mentioned previously, there are 2 copies of every AIP written to a primary tape and a backup tape. This is also true when it comes to data migration. All backup tapes are eventually sent to Iron Mountain. A remote archival facility, Iron Mountain stores physical media like magnetic tapes containing NASA's mission data from older missions. Data may be requested by the space science research community, the education enterprise, and the general public via the Coordinated Request and User Support Office, or CRUSO. Once a request is received, NSSDCA operations staff locates the requested data and provides it to the requester. Data can be requested by NSSDCA Data Collection ID, PDS identifiers, or other assigned IDs. There is no fee to request or receive data from the NSSDCA. Currently, we have over 1 petabyte of data archived at the NSSDCA. However, that number grows daily. In fact, as shown by the archival statistics, the archive has grown by approximately 20% just during this fiscal year. Considering the influx of PDS, plus additional standing agreements that are in place with organizations outside of PDS to archive projects such as PanSTARRS and Goldstone, we could easily double or triple the amount of data held at NSSDCA in the not-too-distant future. To keep up with this influx of data, some future goals include continuing to improve our ingest software suite, automating our data migration process by leveraging additional functionality offered by our new Black Pearl system, a new microservice to be added to our NABS software suite, which will handle read requests, and an overall streamlining of our data request process to make it easier to access archive data. We also have some future equipment upgrades in store. In fact, in May 2025, the SEN installed a new switch for us, which should help improve our networking speeds. In addition, we will soon be reconfiguring our internal network setup so that we can use more direct connections between our server machines and further increase our processing speeds. As we mentioned earlier, we do have some upgrades to our Black Pearl system planned as well. NSSDCA is committed to keep providing secure, accurate, and reliable data archival, preservation, and request fulfillment for our customers, the science community, and the general public.